Tēnā koutou. Greetings to everyone attending this presentation on the Gazetteer development using open source technologies. My name is Christopher Stevens and I serve as an advisor to the New Zealand Geographic Board Ngā Pou Taunaha o Aotearoa, New Zealand's national place naming authority. We're pleased to present on New Zealand's Gazetteer system, which has now been in place for nearly a decade. This presentation is almost a sequel to Chapter 8 of the Untitled Toponymy Manual, written shortly after the system was first released, so perhaps this will give an idea of how far we've come. We're pre-recording given the time difference, but I look forward to answering your questions at the end of this presentation in person. Thank you. The New Zealand Geographic Board Ngā Pou Taunaha o Aotearoa is supported by Toitu Te Whenua Land Information New Zealand, or LINZ, L-I-N-Z for short. This government department is responsible for the governance of property rights, mapping and charting New Zealand, and the collection and distribution of many types of data. The department and the New Zealand government as a whole strongly promote open data and the use of open source technologies. Services, products, and applications are typically freely available to use, and where possible, even to reuse and build upon. For this presentation, I'll cover just a little bit of background, describe our system and each of its parts, and, where possible and where applicable, what open source software and platforms we actually use. I'll briefly share some thoughts on our next steps before providing plenty of time to take any questions. The presentation won't go very far into topics such as the board's jurisdiction, the names actually held in the Gazetteer, and taking note of the time available, not too much on the way of reuse of the data. But we'd be pleased to cover any of this in the question time. Every naming authority will have its own circumstances, background and legacy issues, influencing where they might be placed in their respective governments, what they have jurisdiction over, and the systems they use. Very briefly, the New Zealand Geographic Board is nearing its centenary, with an honorary Geographic Board first established in 1924, legislation for assigning official names in 1946, and with our current legislation dating to 2008. In this time, some print gazetteers were published, with a couple of examples shown in the slide from 1948 and 1968. The 1968 Gazetteer probably represents the first attempt to account for all place names in use on New Zealand maps, and decisions of the Geographic Board are marked with an asterisk. However, our current legislation in 2008 was the first to set the legal requirement to maintain and publish a publicly available gazetteer. However, historically, official names were mainly communicated through publication on maps. So, in the mid to late 2000s, the decisions of the board had to be retrospectively compiled, along with other official names as used on maps, in order to create the first complete place names dataset. A new and comprehensive gazetteer system was required to manage and communicate official naming decisions, and around 2010, development began on the system. And this is what it looks like, simplified as a model. Planning and development, including all the new software components, took about 3 years, from 2010 to 2013, and it was made public in the middle of that year. On the left, the internal parts of the system are comprised of a relational and spatial database integrated with a GIS platform, and on the right, external users mostly see the Gazetteer as the web viewing application, where they can make basic inquiries like, is the name official? What does it mean, and where did it come from? Gazetteer data is also published to a distribution platform, enabling other government agencies and third parties to both download or use the authoritative data as a service. And finally, in the top right, other applications within LINZ and elsewhere use the Gazetteer mainly to provide a search function using authoritative official names. The board's decisions are still communicated through products like official topographic maps, but again, the shift is that the names are now data in their own right, and LINZ will pick up the official place names from the same distribution platform as everybody else. If there's one thing to point out here with the system diagram, it's that it's reasonably modular. The software and technologies that support each role can be upgraded or replaced, potentially with a limited or at least lessened impact on the other parts. And this is exactly what has happened over the last decade. And open source technology really helps here. Next is an abridged timeline of the system development. While it covers a bit of what I've already said, the main takeaway is that we've been very busy for the last 10 years. We've upgraded or rebuilt different parts of the system as our team capacity and our budget have allowed. First, the public-facing web app was completely rebuilt across 2016 to 18, and then another tranche of major enhancements made in 2019. In 2020, our GIS plugin was completely rewritten for ongoing compatibility. And finally, across 2021 and finished earlier this year, we migrated the database across several software versions and to new hardware. With each of these rebuilds, we also put in place more robust processes and support arrangements, which I'll be touching upon more. So for now, I'll run through the 4 parts of the Gazetteer system and what open source software and technologies they actually use. At the center of the system is a PostgreSQL relational database with the PostGIS software extension for the representation of spatial objects. Both of these pieces of software are open source and supported through an extensive community of users. The database is also secure, supporting various modern authentication protocols, tying in with the department's security policies. And from an administrative point of view, it's easy to set up users. The title slide here is just a basic inquiry joining names to features for names approved under a certain process, and the view is using pgadmin for the visual interface, which is another piece of open source software. This also quickly illustrates how we represent place names in our database. Physical features on the landscape, administrative areas, or any other point in space like a historic site are represented with a unique feature ID. And to each feature, one or more names with their own unique name IDs are joined. Other information is then joined to the relevant part, the feature or the name. Most of our day-to-day work is via that plugin for the GIS platform, which I'll cover next, but we do directly query the database for things like statistics or when we need to make a bulk update. As noted in the timeline, we've just completed a major database migration, taking it from Postgres 8.4 to 12.9 and PostGIS 2.1 to 3.2. It also took the server software from Windows Server 2003 to a modern Linux server, once again, a quintessential open source platform. Such major jumps in versions were very challenging, and this mostly came about because the support arrangements from the original system development were weakly defined. Parallel to the migration itself, actually moving the data was to revise and set out new robust support arrangements. So while Postgres 12 will be in support for a while, we do already need to look at a smaller hop to Postgres 14, and that'll keep us in support for several years. We also now have 3 servers and databases. The second is for a mostly separate and parallel system for testing purposes, also publishing to a separate test web application. And for the third, we took the opportunity to improve our disaster recovery arrangements with an independent recovery server. This is on physically separate hardware in a different population center from production and synchronized live to production. Backups are also taken periodically. In other words, if the live database fails, we can immediately pick up from recovery. Ungagan and national naming authorities will know from real-world examples how accurate, authoritative, and standardized geographic names are critical to emergency response. So, it's good to know that our own system is a little better placed whether there's a fire or flood or something more drastic, like a tsunami or earthquake. On a day-to-day basis, we in the Secretariat supporting the New Zealand Geographic Board almost always have QGIS open, connecting directly to the database through a plugin. QGIS supports SQL database connections. QGIS itself is a powerful open source GIS platform, once again with the backing of an extensive community of users and developers, and this includes LINS and many of its staff. Across LINS, there's widespread use of QGIS, and we take advantage of other plugins and tools developed across the organisation. Here in the title slide, I'm looking at satellite-derived elevation data to verify and update the position of a name. Generally, we use QGIS to see place names in their spatial context, as you might expect, putting them over the top of georeferenced maps and to add other layers of information. We use its tools for analysis, to create new information, and then put that back into the database. And for reporting to the board, we can also export graphics, whether an image of the map or something like an elevation profile. This day-to-day use is relatively superficial, considering the great depth the QGIS platform has to offer through its geospatial tools and through automation. For a relatively common task, like defining the extent of a river, we might typically import and edit existing data created by the LINS topographic team. But if the data doesn't exist, we can go deeper and use the processing tools, such as creating hydrological networks from elevation data. The plugin itself is written in Python with JSON, JavaScript object notation, and again communicates directly with the SQL database. The relevant database tables comprising a name are depicted in a plain text panel where they can then be edited. The plugin comes with a suite of tools that interact with QGIS, and vice versa, native QGIS tools can also interact directly with the geometry stored in the database. The plugin also serves to cover most administrative needs, like creating new tables or new system codes if, say, we needed a new feature type, and to define the user permissions. In other words, the plugin is effectively a GUI, a graphical user interface to the spatial database. In the background, when you click the Save button, it's using SQL statements to make the updates. Part of the idea for integrating the database with QGIS was just to train staff on a single platform, in this case QGIS, within a higher level database administration supported by other experts in the organisation. In terms of the original system development, however, a flaw was that the plugin ended up version locked to QGIS 2.6.1. So as the platform continued to rapidly evolve in great leaps and bounds, we were not reaping the benefits. Many workflows would often involve having two versions of QGIS open. 2.6.1 would often cease rendering all objects when it hit a memory cap. Much like the database, this is because the original support arrangements for things like keeping the software up to date were weakly defined. So, in 2020, LINS committed the resources to upgrade the plugin from QGIS 2 to 3 and Python 2 to Python 3. All the errors and issues were managed through GitHub as a typical DevOps project, and the result is that we're no longer version locked, and as QGIS continues to evolve, we can move along with it. The development did require a significant amount of time from the Secretariat team for testing, but this also served as a future-proofing investment because all the user tests for the plugin's functions were automated. Should future versions of QGIS again become incompatible, we should be able to identify at what point the plugin has failed to shorten any future development. Moving across to the external-facing part of the system, the New Zealand Gazetteer for the general public's intents and purposes is the front-end web application at gazetteer.lins.govt.nz. Users can search on place names, filtering by status, feature type, within various administrative areas. It provides logic for partial matches, accounts for diacritic marks, and presents all results in an interactive side panel that also highlights official names. Users can also browse the map to show all place names in a given area by panning and scrolling, and whichever way they search, the results are presented over the top of either a combined LINS topographic base map or a simplified land cover base map, including bathymetry to the edge of New Zealand's continental shelf. The information will at a minimum include a reference point, and if it's available as it is for maybe half the features in the Gazetteer, feature geometry like lines and polygons, as you can see in the title slide. In 2019, some of the enhancements we made included adding patterning to try and improve visual accessibility and user options so that people can change the colours and line weights as they see fit. This part of the system has been completely redeveloped, rather than just updated like the plugin and database, so it might help to give more of an account of the development. The original web application from the system released in 2013 was a small map window embedded in the LINS website. It allowed text searches over a simplified topographic base map. This part of the system was developed externally, supported by a New Zealand IT infrastructure supplier. But it turned out the application as built was somewhat monolithic, making the enhancements we were after quite costly. This was almost a minimum viable product. Changing anything affected everything. Having been embedded on the LINS website, there are also clashes with Drupal, the open source web content system the site was built in. So, while preparing a business case for the updates we were after in 2015, a team from the provider pitched a complete rebuild based on the open source JavaScript mapping platform Leaflet. Although the development did end up a bit elongated, the end result was far superior. First, the application was put on its own fourth-level domain within the LINS website. This immediately removed all the issues with Drupal, and also took a small step towards maintaining the board's identity as a separate statutory entity. It also enabled us to use the name IDs to give every name a unique URL, which has had great benefits in linking up data. The new application front-end was built on Leaflet and the JavaScript, React, and Redux libraries, again, both free and open source. And for Leaflet itself, there's a wide community of users and developers creating their own modules, so being able to adopt some of these shortcutted the required development from our end. The backend to the application is built in Ruby on Rails, and this communicates with the Gazetteer database, picking up an export table using Docker to securely move the data. It also sits on Amazon Web Services and again uses Docker for load balancing. While this remains developed and supported externally, the full code of the redeveloped web application, including all enhancements, is openly published on the LINS GitHub account as part of our supply contract. And again, with this major redevelopment and through ongoing tranches of enhancements, we've created more comprehensive support arrangements. The final part of the Gazetteer system is the method of data distribution. This is managed through publication to the LINS data service, a platform developed by a third party called Coordinates and used by all of LINS. This platform is based on Amazon Web Services, which has a major service centre in Sydney, meaning the performance is excellent. And just out of interest, has received approval for a new centre in Auckland shortly. The open data ethos is perhaps expressed here in its most obvious form, because anything from new LiDAR to this year's latest aerial imagery, all official maps and charts, and the layers of information making up the products can be downloaded freely, typically under a Creative Commons attribution license. For the Gazetteer, users can download all names as a layer, with separate layers for the vector lines and polygons. Though not all follow open specifications, people can download the data in a wide range of the most common file formats, and though a little less relevant given the size of the geographic board's datasets, all the vector and raster information can also be reprojected using the power of the Amazon cloud before served up to the users as a download. Through the platform's management functions, our layers are set up to just read the Gazetteer database daily, so the layers are refreshed if the changes are found. Our layers can be connected to as live web feature services through an API, as long as the users create a free login account, and there are change set services available to likewise identify and update just differences found on each publication. Publishing Gazetteer data to the LINS data service ensures our compliance with the relevant Australasian and international metadata and geospatial standards. Through the management functions of the platform, we can also see just who has been downloading the Gazetteer data or using it as a service. And far and away the most prolific users are those we've signed data sharing agreements with, like the international site marineregions.org. After that, as you might expect, various local government councils across New Zealand, Crown science agencies, and many engineering and consulting firms make up the power users. Moving into some of the lessons learned, you may have already gotten a good idea of them. For the initial development of the system, two major considerations were the costs for proprietary systems and licensing, and that LINS as an organisation actually possessed a great depth of knowledge and skill. Therefore, most of the system was built in-house. In the open source languages and software, there was already a great depth of knowledge in. And I wouldn't be exaggerating to point out that the original database, plugin, and export functions were all built by one exceptionally skilled person. But while years of planning and development went into the system, like the conceptual models, specific technical details, and the software, after going fully live in 2013, as you've heard, we found the support arrangements were insufficient to keep everything up to date, let alone upgrade anything, whether this meant securing the time of skilled people in LINS or the budget to contract externally. And the thing about not keeping current is that it becomes more difficult the more outdated your system becomes. Thinking about the database especially, Postgres 8.4 was almost end of life at the time our system was released. So we had to step through several versions of the software, testing everything was still intact at each stage, making the migration much more complicated. The main lessons from the development and redevelopment of the Gazetteer are almost sides of the same coin. While our relatively modular system has advantages, and it does come with a potential overhead because there are more pieces of software to keep up to date. Much of our system is built on open source languages, on open source platforms, and we use more open source software to manipulate it, and they are literally free. But you need the skills, time, and money to build, maintain, and improve it. As we've rebuilt the system, these arrangements are now in place, though at an increased operational cost, including those inescapable costs like keeping the lights on. Each part of the system has to live somewhere, and it costs money to keep running, to maintain, to test things like disaster recovery, and for information security. So another aspect is the skill needed to operate such a system. The board needed a robust new system to support its functions as the times changed, and that system in turn changed what kinds of skills were needed to support the board. Our Secretariat team requires a reasonable level of understanding of how everything works and the specialist skills to operate it. These are quite different to what was required prior to 2013. All of the Secretariat has completed some formal training, like courses in QGIS, though is mostly learned through nearly a decade of using the platform. Thinking back to what I said about the plugin, while the intention was for the Secretariat to use it as an all-in-one, relying on others within LINS for more advanced needs, it often didn't quite work out this way, especially when we needed information on a more timely basis. So, to bring some more skills in-house, I, for example, have learnt enough SQL to take over the day-to-day database operations. But we are still quite operationally dependent on other people in the wider organisation, especially when we go to enhance things. Going forward, we could continue to try and upskill our staff as required. Alternatively, we could upgrade the plugin to add that more complex functionality, like reporting functions. A more significant departure could also be to look at the team structure and weigh up if somebody should actually have specialised software development, coding, and database management skills. But given the size of the team and that our role supporting the board also encompasses other skills beyond this, it might be difficult to justify. So now we're moving away from the core part of the system to the actual use of Gazetteer data, which is the whole point. Fundamentally, in New Zealand, official documents are required to use official names, and official documents are almost anything produced by government, whether data, reports, or a physical road sign. Official documents also include scientific publications and publications intended for travellers and tourists. So in this first example on the right, we have the LINS topographic map with all Tōtaranui names spelled with a macron on the O, as decided by the board, and on the left, encouragingly, the relevant local government authority Tasman District Council likewise spells the name correctly. But here, I'm going to talk a bit more about reuse. As alluded to earlier, Gazetteer names also provide a search function in applications. In this example, for the catalogue of electronic navigational charts and digital hydrographic charts, using the Gazetteer names in the search function, it'll take you to the location and give you all charts at all scales that intersect with the chart boundaries. It also uses the linear and polygonal extents from the Gazetteer, such as in this example for Whakaari White Island Canyon. In this next example, Land Online, New Zealand's Survey and Title System repository also pulls a small extract of place names from the Gazetteer to similarly provide a search function. So here, I've just searched Ngaruawhia, and now you can see New Zealand's cadastral fabric, the property parcels in the area. Similar uses of Gazetteer data are also to refer to an authoritative source for place, not specifically compliance, to just help spatially reference records. Here, Antarctica New Zealand have their multimedia catalogue, their photos and reports, grouped by place name from the Gazetteer. But having a national authoritative source of place names is also important for reuse by third parties who want to get things right. In early 2019, we had a meeting with Wikipedia's Wikipedian at Large, somebody sponsored by the Wikimedia Foundation for New Zealand. Not long after, the New Zealand Wikipedian community agreed on a policy to use the official geographic name for all article headings. Here you can see Metatoto, Ship Cove, an official dual name. Thanks to the rebuilt web application where name IDs provide a unique URL, we now have some 21,572 Wikipedia pages linking back to the Gazetteer. Wikipedia is now the third most common vector to the Gazetteer after redirects from the LINS website or from a search engine. And as Wikipedia articles are reproduced across many platforms like Google searches or Google Maps, so too are these official names. Google itself has begun more systematically ingesting Gazetteer data, particularly with a major update in early 2021 when they refreshed some of the way they depicted mapping data. Many decisions, such as adding macrons to Māori place names or for official dual names, can now be seen in Google products. Making these kinds of connections with third parties really does affect change, because if the official name is what people see on a day-to-day basis on all the things they use, it really does make it real. Some other reuse cases. In this example, we have a third-party cartographer and digital mapmaker who reuses Gazetteer data along with data from other sources, including for commercial use. Next, Gazetteer data is also used for linguistic research. Tupanaha, Matatini, and Dragonfly Data Science created new text recognition software to recognise Te Reo Māori, the Māori language. by training it against the New Zealand Gazetteer. This map shows the results of place names which do, or do not, appear to contain Te Reo Māori. You can see in this blown-up version of the map in purple areas of significant overlap between the two, otherwise with Māori in red or no apparent Māori in blue. And there's a very distinct geographic distribution. They've then gone on to use this tool for things like measuring the amount of Te Reo Māori spoken in the New Zealand Parliamentary Hansard over time. We've also had a number of researchers sit in with us at the LINZ office, usually to research a particular place name, but sometimes to study an entire body. In 2019, we had a PhD candidate from the University of Glasgow, Scotland, looking at the influence of Scottish naming in Otago and Southland regions. This map shows waterways across New Zealand using burn rather than stream or river, and you can see the clear geographic distribution. So what's next for the Gazetteer system? I'll emphasise one more time that we've now put in place robust support arrangements, and hopefully this will keep software currency from getting out of hand. But the updates will still require our time to define and test. What is likely to be a big project in the near future is another rebuild of the web application. Having conducted user surveys and kept track of other incidental feedback, it is a bit mixed. The Crown Agency, Manaaki Whenua Landcare Research, use the Gazetteer for freshwater research and consider it to be easy to use, but many others, including the general public, don't find it intuitive whatsoever. We've also run into limitations of the open source leaflet platform. For example, performance is affected when there are thousands of results, and this is probably because it's browser-based. To achieve a seamless and intuitive experience we want for our users, the board will also have to meet their expectations in terms of the actual content, the data. To take one example, we've recently imported about 7,000 new entries for history in agreement with a book publisher, and will shortly be contracting an historian to begin producing more content. We also want to see the Gazetteer understood, acknowledged, and more widely used by those both that legally have to, but also more broadly. For a start, while all of government and some third parties are legally required to comply and use official names, this doesn't necessarily occur on a voluntary basis, especially when they're not aware of their obligations. So in terms of a regulatory model, you could say we'll be moving away from voluntary compliance into something more proactive, like assisted or directed compliance through education. The legal framework exists and our robust system makes it all technically possible. We just need to bring everybody on board. We can easily imagine an ideal future of machine-to-machine connections across local government, regional government, and other agencies, informing their systems and products as to what the official place names are. Across third parties, information about place names could likewise be linked up. The Alexander Turnbull Library, which holds the manuscript collections of the National Library of New Zealand, has now incorporated Gazetteer name IDs into its thesaurus, though we wouldn't probably serve up multimedia through the Gazetteer. As more of these links are made, it does mean that cross-government and cross-institutional information about place could easily be pulled together. So with that, while our imagination and ambitions might be unlimited, and I can continue to go on with our plans, our resources and your time are not. I'm sure we'll present again to Ungagan in the future with another chapter on the development of our system. And with that, I'll end the pre-recorded presentation and say hello again in person, and potentially answer your questions.